The original video is on the left, and after the face swap, the result is on the right. What are your thoughts? The first run took 375 seconds to process 121 frames on my 4060 Ti 16GB system. Later, the processing time was around 300 seconds. The image I used here has a facial structure similar to the woman in the video. A person with a round face should be challenging. The hair you see at the beginning of the video can be fixed with a face swap workflow. But right now, we need to see how accurately the face is being generated. This is not 100% accurate, but it does not break when the character is in movement. The model fails to mimic the exact movement of the mouth and may not perform the activities you might think. But the facial expression should work. Thanks to Pavel Danilyuk on Pexels for making the resource available to complete these tests. Link to the video I used will be in the description. Now let's look at the workflow. This may look complicated to some beginner, but it is not. The workflow and the Head Swap Lora are from Hugging Face, so make sure to read the disclaimer before using this content. Below are some results that look interesting. I made a video previously on face swap where I showed the difference between face and head swap. So make sure you check that video because it may help generate the first frame, which is required in this face swap process. The same has been mentioned here. It says about the model, which is the safe-tensor file I am using as a Lora, is trained to use the first frame, which becomes a condition for the entire video generation. The Lora strength we need to use in this process should be at 1. Strength higher than 1 can improve the parts around the face, but it may not follow the original video. The result can be improved by processing the latent result multiple times. You may know LTX processes the video twice, and using this Lora during both the sampling process can refine the final result. Prompt has no effect in the face swap process. The Lora is trained to follow the first frame. A few problems you may encounter are problems with the hair and hard transitions between two characters which I have not noticed yet. The next version is in progress, and hopefully this should work with a single image someday. You can support the Lora training from this coffee button. In the Files and Versions tab, go to the LTX folder, and you can download these two files to begin. Actually, you need the first file only to begin with the LTX workflow. I have not tried the second Lora, which seems to be for the first and last frame. The logic of using a frame must be similar, but instead of using 1, this Lora must be using 2 frames. So this Lora is the additional files over the regular LTX files. In the workflow, let's take this section and understand what's happening. I will paste it separately so it becomes easier to understand. The files we need to select here are the common files we use to run the LTX workflow. This GGUF node with the Q6 GGUF diffusion model works. And you can try this on a system with smaller memory. But the one you saw in the original workflow was from the FP8 Distilled transformer. After the diffusion model, there are 2 files selected in this clip node. Next is the video VAE, and then the audio VAE. And at last, there is the latent upscale model. This video chunk node connects after the diffusion model, but I have not used these because this is new to me. So, this is where we need to upload the image of the person we want to be in the video. And below is the video. I will run the workflow so that we can see the image. This image here is the first frame of the video I have uploaded. So now I have the target frame to begin with the image of the person I want. This node takes both the image, the one we want, and the first frame from the left. And here we can manually put our character on the frame. Once it is positioned, run the workflow to set the value in this set node, and then it will be used further in the workflow. So this was a method to have the woman from the video with the face we want. Below is the second method, which does the same work automatically. The title here says Head Swap First Frame using Flux Klein. The diffusion model selected here is the Klein 9B model with a Head Swap Lora, clip text encoder, and the VAE. The Flux workflow in this subgraph takes the first frame and the reference image, which is the image of the person we want it to be, and does the head swap on the first frame. The result generated is given out by the workflow. And this is where the different hair comes from, which we saw in the video at the beginning. The image is then set in this automatic position node. So now we have the manual and the automatic head images. Both images are kept here, and only one continues after this node. When the switch is false, run the workflow. The set start frame node gets this image. And if it is true, run the workflow. Then it passes the automatic head swap image. The one image passed through this node is then used further. I will run the workflow, and you can see that it takes the set frame and the body reference. This body reference is the entire video. This node group had replaced the first frame of the video and was saved in the control video node. The same node will be used in the LTX workflow with the head swap Lora we saw on Hugging Face. So that was this section. Moving further, this section is about processing the audio, which has been explained multiple times, so I will move to the LTX workflow. Keeping multiple images in this preview node will impact the computer's performance. It's better to reload the node and bypass it. All the frames from here with the edited first frame is being used in this workflow. This section is about models, text encoders, head swap Lora from Hugging Face, and prompt notes. All goes to this condition node which guides the video generation process. These nodes, I think, are not useful, so I removed them. The start frame, which is the edited frame, goes here, and we are taking the resolution from it to create the empty latent video. Below is the number of frames from the original video, which will help us to match the length of the latent video. The empty latent with the first frame goes here. And the control video frames we saw earlier also goes here. So the video latent is ready and the audio latent as well. You can use the audio generated by LTX or get the original audio node. In the sampler, this set guider and get guider nodes are making a connection. And you can connect this and use a different set of nodes for guidance. I have not used these nodes yet. The sampler output is separated and all the values are taken so we can process the video again. The output at this stage can be decoded here. And the same is shown on the first result. These set and get result node shares the result, and then taken here to show the video. Next is this upscale section where I am not using the upscale Lora by LTX. I'm using the head swap Lora. This is simple. The model and Lora are used, and then there are two guiders as we saw before. I'm using this as I did before. This get result without G node brings the result in latent form, and it goes into the video latent to get processed again in the sampler. The two results, one for comparison and the other to be saved as the final output. Both can be obtained after the video is processed for the second time. So that was the workflow. I will quickly name it as LTX. And this is after latent upscale. Actually, it should be named as processing the LTX result again. This is the switch to pass one image, and this is face swap frame 0 with all the video frames. There is a different workflow uploaded on Hugging Face, which I tried. The result looks bad. I tried increasing the steps and also used the dev model. I will update if this turns out to be a better one. To make things a bit simpler, I will be sharing these two folders on Discord. The folder contains the video I used and the image to produce this result. You can drag and drop the result on comfyUI, which should load the workflow. Save this workflow to begin. Links to the models are given on the left. The files required for Flux are one of these diffusion models, text encoder, VAE, and the head swap Lora. Next, you need to get the LTX diffusion model, any one of these. I was using the Distilled FP8 file. Get both of these files from the text encoder and the VAE section. And then the Lora. You do not need to choose the Lora from here if using the Distilled transformer. But get this head swap Lora. Latent Upscaler, I did not use it. I tried in the new workflow, and I'm still trying to figure out the reason for the bad result. And this file is to separate the vocals from the audio file. Save it in the diffusion model folders. If the Lora link is not found, check the description. So that is it in this video. I hope you find the workflow interesting, and I wish you an excellent day.